again. Let me welcome you all in our first session of the series of the webinars that Pakistan Chemical Manufacturer Association is holding. As you know that the topic for today's session is chemical bioeconomy, sustainability and global opportunities. And we have Mr. Thodas as a guest speaker. He's expert in the field and he'll be taking over this session. So, as we all know that bioeconomy or biochemistry is fast assuming the role, and Europe and America.
We'll save this and we'll put 3 lakh rupees towards crypto mining.
Can you hear me? Yes, sir. So I was saying that the importance of biochemistry or bioeconomy cannot be overemphasized due to its fast coming up numbers and the fast switching over from chemical or other products like the sources which are not very sustainable, and Europe and America, who have this sense, have already moved and switched in a big way. Pakistan, being a agri-based country, has a lot of potential to tap this sector and reap the benefits which others have already taken. So I think the future is biochemistry, and bioeconomy. So, and its importance, as I said, cannot be overemphasized. So I therefore welcome our today's speaker. But before that, let me hand over it to Mr. Mohammed Saib, who will conduct this seminar any further. Thank you very much. Okay, Mr. Saib.
Thank you, Balsa. Now I would like to get our guest speaker, Mr. Thodas from Netherlands. Mr. Thodas is a chemical engineer working as engineering manager products at Croda. Croda is the name behind high performance ingredients and technologies in some of the most brands in the world. Last year, Mr. Thodas was listed on the Forbes 30 Under 30 award for his work in manufacturing and industry. At Croda, he has worked on capital projects, process development, process improvement, innovation, and sustainability. Outside Croda, Mr. Thodas is passionate advocate to sustainability and is a Europe Climate Pact investor. Thodas also has a role of European Federation of Chemical Engineering Executive Board member and as a Global Engineer Futures Advisory Board member. So without any further delay, I would like to hand over this session to our guest speaker, Mr. Thodas. Please.
Hello, thanks for inviting me. And could you allow me to screen share, please? It says host has disabled screen sharing, just a technical issue. I'd like to say thanks for inviting me and thanks for having me. I think Croda actually is one of the companies that has been doing bioeconomy before bioeconomy became so interesting. So it's a really great opportunity to be here. And here we go. And as said before, I think Pakistan has a huge amount of potential in bioeconomy, and being an agricultural country, and they have a huge amount of raw ingredients for the bioeconomy. So this could be something that you could tap into. So without further ado, I'm gonna. So a bit about me. I went to University of Manchester back in 2008. Actually, while I was at university, I was sponsored by Procter & Gamble. So 2009 to 2012, I was in intern, worked for Procter & Gamble, who were behind big names like Gillette and Pampers, and things like that. And then when I finished graduating, I decided, I really liked the chemistry part of chemical engineering more, and I tried to get different roles and actually not go for Procter & Gamble. So I joined Croda in 2012. Since then, I had some few different roles within production and within engineering. I already had a glowing introduction. Right now, I'm working on innovation projects. So I'm working on the future of Croda. Some of those are really linked to sustainability, like trying to reduce our emissions by 50% in operations, global emissions 2030. So I'm doing some of the decarbonization roadmaps for that, for all of our operation sites, coordinating that. And also some of the just new and innovative technologies around the bioeconomy area. So who are Croda? This is a 2019 map. We've since made some acquisitions, so we're even bigger and in even more countries, but it's an international company. We have manufacturing facilities all around the world now, and we did start off, based as a UK company, but now, and we still have more. We have 5 of our manufacturing sites within the UK, but we have multiple sites in US and Brazil. We have sites across Asia and across Europe as well, and we're looking at 1 billion turnover and a good 300 million plus profit and 4,500 employees around the world. So although it's not a company that many of you have heard of, it's a company within the specialty chemicals business that's doing pretty well. And it's a company that makes its base ingredients, always has really, from the bioeconomy, essentially, oleochemicals. So its base ingredients are coming from animal fats and vegetable oils, and they're transforming those into specific chemicals with benefits. So, and what has Croda been doing in the last year is, if you want, well, the share price is, the financials, the way that some people just look at, performance, right? And Croda has been around for, 100 years. And if you look at since 2008, basically on this chart, we have skyrocketed, and we're tripled already from 2011 in terms of share price. So that's telling you how much future the bioeconomy can have when you do it right. Not saying that it's going to be an easy road, but I'm saying that right now, with sustainability being at the core, sustainability can make you good money, and bioeconomy can make you good money. It doesn't mean, sustainability does not mean that you have to lose money. There can be such a thing as the green economy, right? And that's what we're trying to do. We're trying to make of that win-win situation. I believe when you look at things through a different paradigm, you restart, and how you're looking at businesses, you will see sustainable business models and ways to create money out of biochemistry instead of traditional chemistry and fossil fuels. So what are we actually doing? So when we're talking personal care, so for instance, our ingredients will be going into facial creams or into shaving foam or toothpaste. If you're talking about healthcare, we've got ingredients in the Croda vaccine, which is in the Pfizer vaccine. So that is one of the big things that we're working on now. We had to do scale up, build whole factories from scratch to be able to make those ingredients. So for the whole supply chain of Pfizer, that was, world record innovation. And we're very proud to be part of that. But also in several different parts of pharmaceuticals and medicines we're involved in. So crop care, you can think about fertilizers and seeds, but and more traditional things like paints, plastics, lubricants, like engine oils and that kind of thing. And soap care, home care, you can think about soaps, geotechnologies as well. And so
तारें उसमें तीन तारें लगी होंगी वो तार दीजिएगा.
Okay, yeah. So yeah, we are from these oleochemicals, we're able to make these wide variety of products. These are some of the products. An example, because it's a specific ingredient, so these are some real examples of what that looks like. So we're talking about, for instance, in the LCD screens on TVs, we've got special ceramic components, in solar cells. We've got, for instance, products that are going into the dual clutch technology in cars, or we've got water repellent products which are going on our phones. And I think we've got some water repellent products on cars as well. And I think water repellent is a really nice example of it, because if you just look at a car when it's raining, in UK it rains a lot, by the way, so it's a good example in UK. I'm not sure how much it translates to Pakistan, but those droplets don't splat. They kind of stay whole and they drop down to the bottom. And that means that you have really good vision when you're driving. Why do those droplets stay whole like that? That's because of water repellent. It's like working like magnets. So it's not hitting and crushing, it's rather staying whole, and it's easy. So we've got different stuff going into these different chemical names going into these different products. And this is just a range of some of the stuff that I work directly on, but you can translate this into all the previous sectors, which I showed before, which some of my other colleagues have been working on. And so we've been doing bioeconomy for a while, so when I'm saying we're making, 70% of our stuff from bio, so the main, so it's from the bio sources, and 30% is more coming from, fossil fuels kind of thing. But at a certain point last year, we decided to launch a new commitment. And we said we're going to be climate, land, and people positive by 2030. And what does that mean? Because that really means that, we were linking up with the UN SDGs. We're looking at how we can be a more sustainable company with, just integrate what we want to do with the existing structures and the existing kind of measures of sustainable development in the world. So in sustainable development goals, there are things about industry and innovation and about climate action. And there are things that these are things that we need to bring into our strategy. So some of the stuff that we're doing in crop care, for instance, it's helping to feed the world, which is one of the goals of zero hunger. So that's how we were able to link and really see, are we doing the right thing? And this is just a quick what the goals look like, but really so when we're looking at the products we make and what we're doing and what we want to do with our vision, we can fit those into some of the, not all of them, but a lot of them that are already there. And then we know, hey, we are contributing to a better world and we're making a lot of money but while we're doing it. And because at the end of the day, we still want to make money. That's why we're a company, right? So, yeah. And in terms of climate positive, we had some what we call hero goals. So what does that mean? We decided we want the use of our ingredients to avoid 4 times the emissions that is associated with the business. So when we say the use of our ingredients, we mean if you would not use our ingredients, in a lot of cases, you can choose to just skip our ingredient altogether, or you can choose to use a petrochemical alternative to our ingredient. And what we're saying is if you use our ingredient, we're going to save emissions 4 times. So we are bringing 4 times the benefit, which means it's beneficial to the world, these ingredients, rather than, because one of the problems we have in the world is consumption in general. So you want to make stuff that is good for the world, right? And we also said in terms of science-based targets, we want to reduce our emissions by 50% because we want to keep the temperature rise to 1.5 C. So, and we said right now 70% is bio-based. We said we want to make 75 bio-based. This all by 2030. So we're going to push even further to bio-based organic raw materials. And we're already looking now in the products where we're using, materials from fossil fuels. We're looking, hey, how can we do this with another product? How can we change ingredients? How can we get the same functionality? Because that's what it's about. It's not about what the product's called. It's about what the product does. So the client has a need and we need to meet that need, and we can meet that need potentially with a whole range of products. And so you have to get creative, and that's what our R&D teams have been doing. In terms of land positive, it's very much about the land that was going to save from improved yields of some of our products. Is going to exceed the amount that we're going to use to grow our materials. So we're just going to that's sustainability, giving back to the earth. And we want to have, breakthroughs and partnerships with the farmers, and the crop care and seed care part of our business is a really key and critical part of the business that we've been growing, because we really believe in that zero hunger, and with climate change and effects of climate change, we need to get more creative and better products to increase those efficiencies. And actually, some of the crops as are coming back to Croda, because we are also using natural ingredients, and more dependence is going to be on natural ingredients as more companies switch away from fossil fuels. So we're going to need to find more ways to make these natural ingredients on the same amounts of land. And people positive. So, and this is a lot about, the stuff that we've been doing with the vaccines. We want to be involved in 25% of the WHO listed vaccines, and by 2030. And, by 2024, actually, we already want to be involved in 25% of the pipeline of the WHO listed vaccines. And as I said, we're working very hard on Croda vaccine and the manufacturing on the Pfizer vaccine and the manufacturing of the ingredients into the COVID Pfizer vaccine. And as well as that, another thing that we're doing is, we make some, as I said, some skincare products, and some of those are, as for instance, sun care products, and we want want to help people from save them from skin cancer. So this is part of what we're trying to do with the bioeconomy. I think one of the big challenges when you're doing all this, right, is that yes, you're going to use raw materials which are organically sourced. So raw materials that you can, for instance, probably put back through sustainable forestry and stuff. Your raw materials, yes, they're going to have a benefit because you're going to say we want to, have 4 times the carbon cover, the 4 times the benefit to the world than what we're using, what we're causing. But at the same time, there's a shortage there's going to be a shortage. If everybody decides we all want oleochemicals, there's going to be a shortage, right? And at the same time, population is rising. So you just need to be smart about what you do, and you need to reduce the total emissions, the net emissions. So that's in Climate Positive, we said, hey, we're going to reduce 50% of our emissions anyway. And that's not necessarily from only using organic raw materials. Some of that is from what we'd say novel technologies. So we're talking biocatalysis instead of using heavy metals for catalysis. You can potentially, or you're not having catalysts, you can potentially do something at a lower temperature. And if you do it at a lower temperature, then less heat input, you're reducing the energy usage, you're reducing the emissions. So these are kind of technologies summing up how we can use natural things, enzymes, yeast, these kind of things to really and to really understand and take inspiration from nature, but not only take inspiration, but make products with nature. We're tapping in and we're partnering with specialists in that as well, and some of that is through acquisition in these new and novel technologies. And another thing that we're doing is process intensification, right? So we are changing the current processes that we have. The current processes, they are from, some of the plants are from 1970 or 1980 or 1990. Technology has gone further in those 20 years. And, you can, in some cases, you can bring processes together. So that's, instead of having 2 separate parts, you can do it in a smaller unit. You can do it on a unit with less energy. That's what we're doing now when we are putting in the new units. In terms of what else that we're doing, when we're looking at the existing plants, it's very difficult to put in a novel technology or to, retrofit. And so what we're doing there is, we're doing a lot of heat recovery. So with the energy, so, making sure all the waste heat is, and the product heat is coming back to the feed, and we're using heat pumps, to upgrade some of that waste heat so it can be reused again. And at the end of the day, no matter how far you go, you still got a bit left over. So the what we're doing at the end is still, electrifying and changing for renewable energy, whether that's wind and or another type. So and all of this adds to also reducing that 50%. It's not that easy, when you hear electricity costs twice as much as natural gas, you have to get creative. There's a reason why the fossil fuel products and fossil fuels have been going around so long as they have. So you need to find a way to do both. So that's why we're doing all these novel technologies as well as replacing. That's why with Croda we have been making specialty chemicals, value added chemicals, And these chemicals, yes, they compete directly with the fossil fuels, but but we have a reason, and sometimes not just sustainability, sometimes to use our product, a quality reason, a functionality reason, and this is how you can win, essentially, and you can have the success that Croda has been having. So in terms of Croda's carbon emissions, you see that since 2006, we made a lot of steps already, but there's a long way to go for 2030, and the company is growing, so that's why it goes in yo-yos. Every time you make a step, you also make an acquisition, and then you go back up, or you don't make an acquisition, but you just have more sales, so you're getting more and more sales, and you're trying to reduce the emissions more and more. So you have to be, you have to really put your money where your mouth is, and really also think about your product portfolio, because some of the products that you make are just inherently going to cause the carbon emissions. So sometimes you think, hey, we're going to make a different product, maybe for the same function, in order to reduce those emissions. Now, something that I did earlier, we did a project which which reduced emissions by 25%. That's why we called it quarterback. Gave a quarterback to the environment from 2013 to 2017 in the Netherlands. And a lot of that was from, replacing natural gas with biogas, which we had from our own product. And part of that was removing a concentration step and also energy efficiency improvements, all linked to what we were doing with that. So what was it about? It was actually a demonstration project. We had a waste stream, or not really a waste stream. You could just say it was a low value product stream, glycerine, and we used it to generate our own biogas, by therefore eliminating a concentration step. If you see anywhere that you are boiling water, that is one of the most energy intensive processes that you can have. Processes like this is something that you need to think again about and see how you can eliminate it, do it differently. So we removed that and we put in a gas motor, which was a new, which increased the efficiency as well. And that's how we got the quarterback of energy, and also got that, EU demonstration subsidy and several prizes for that. So that really sums up what we've been doing at Croda with the bioeconomy, and it's now open for any questions that people in the audience might have.
Yeah.
Left bottom. Here it is.
Yes, I have a question. Please, you mentioned. You mentioned something about novel technologies. I would like you to elaborate on these. How can we lay hand on those novel technologies in order to implement this bioeconomy?
Yeah. Okay. So in terms of novel technologies, there's for the bioeconomy, we're talking, if you're doing a bioprocess, it looks different to the traditional chemical process. There are, of course, similarities in that, mixing is mixing, but the mixing actually is way more important when you've got for instance enzymes involved or yeast involved or something. And if you're and the idea that biotechnology is new is not necessarily because we've been, making bread for years, and that is biotechnology there, right? Bacon with yeast. So what we're doing now is reapplying some of the things that we've been doing in nature for years. We're reapplying it to make another specific product. In terms of when you're using other novel technologies, you're using just organic bioeconomy. So you're just using organic products, a vegetable oil or animal fats. It's traditional chemistry that's going on there. But in traditional chemistry, you can have a radical reactor design. You can have a reactor design that is just coming from a university, Actually, what we've seen is that there's been, in terms of what's available at university and what's actually in industry is relatively slow to take up because they are scared. But the key to it is, to do scale up stage and to adopt it because somebody has to be the first. So at Croda, there's something called a continuous oscillatory Baffle reactor. We decided to be the first to take that process to scale. So it's been, studied at universities, and that process is basically, it's a tubular reactor. It's got baffles in. So it's got baffles in, which are like, just making sure that the thing goes like that. But also it oscillates. So the whole reactor goes up and down a bit like this. So, and this gives you fantastic control on your mixing, on the flow, on the temperature distribution. And you can, for some of the pharmaceutical reactions, products, this is really important in order to get the best yield. And so this is what I'm talking about as novel technologies. And you don't necessarily need to invent them yourself because there's a lot of inventions out there, but you need to have the bravery, the courage to try them and be there and be the first and find the application. I didn't hear your question.
It's not actually a question, it's just a comment observation that there's a chat gallery. There are so many questions that participants are putting on. So can you read those chats by any chance? Or should we?
Hang on. How can we replace heavy metals with biocatalyst? So that's the cases. You've got two cases, right? You've got to look at the reaction that you're doing. So if we're doing a hydrogenation reaction of, say, a fatty oil like palm oil or something, and they're often going to use nickel or something like that, a heavy metal. Now, the reason that you're using that is, of course, to speed up the reaction and to get the reaction further. And now you can think to yourself, okay, don't use any catalyst and just do it at a lower temperature. But then you're not going to get as far in your reaction, and you're not going to get as far in the kind of speed that you want. So what you can do is you can look for potentially enzymes that can recreate the same result. And in some cases, there's not necessarily an enzyme out there yet, but you can use stuff like screening to find enzymes. So we're actually using the capability of AI to do that research much quicker rather than experimentally. It's doing that, really via digital technology. And then in other cases, what you can do is called directed evolution. So you find, okay, there's nothing been made yet. You go to a company like Genentech, Novozymes, or any other kind of biotech company, or maybe a biotech company or small biotech company within Pakistan, maybe a spin out from one of the universities, and you say to them, this is the products that we want. What you do is directed at evolution in order to get these properties. So that company will then create conditions which force the enzymes to evolve towards the enzyme that you need. And then you end up with an enzyme which is essentially replacing your heavy metal. But another question is also, you can just make another product, right, that does it. That's the third question, because sometimes the enzyme can't exactly replace your heavy metal, but it can do something else, something better, let's say, or different, but it can have the same product function. And in this way, you can also replace your heavy metal with Biocatalyst. So is any pact like Kyoto Protocol included in your project? So we're not necessarily looking at the Kyoto Protocol when we were looking at our targets, but we did look at science-based targets, which is from the Paris Agreement. So it's similar, but it's from, Paris Agreement was in 2015, a little bit later than Kyoto Protocol, and where we said, hey, we want to keep global warming to less than 1.5 to 2 degrees. That was in the Paris Agreement. So we're taking that also 1.5 degrees. So we're taking that same strategy. And in terms of our target to reduce the emissions, that's completely in line with that. And in terms of the rest of our strategy, we're putting in line with the UN SDGs. And if they make new SDGs, Sustainable Development Goals, we'll update that as well. So that is included, and it's a really major part to make sure that you are not just pioneering in the way you're making your products, or the raw materials you're using, but you're actually we're making a plant. Now, if you make a factory now, the factory has to be, doing the right thing for the next 20 years, not just now, but for the future. Another one. Do you think electrification needs fossil fuels? So if so, how is it environmentally friendly? Potentially yes, but hopefully no. Electrification depends on the grid. So when you electrify, then you just get energy from the grid, and you hope that your country moves towards lower energy intensity. And most countries will move towards lower energy intensity in the long run. So it's still better than burning your own gas in any case, because most countries, they have some part of their electricity grid is renewable, and some part might be nuclear, for instance, already, which is low. And so it's still better than, just burning your own fossil fuels, even if your country isn't completely renewable, which there's very few countries in the world that are. Do you have a bio replacement for polyolefin polymers like polyethylene? Now, I can't speak on specific products, but, people are making bio replacements for plastics. You're seeing now companies making polylactic acid, for plastic bottles. It's been widespread in Europe. So instead of making PET bottles, they're making, polylactic acid bottles, and coffee cups and all that kind of stuff. So yes, you can make, it's not polyethylene that you're making then. Sometimes you can make the same product with bio products, but sometimes you're going to make a different product. but with the same properties. And that's what you've got to look. What is the thing supposed to do? So a tubular reactor does not have baffles, no. But that's the idea. Typical tubular reactor doesn't have baffles. It has maybe a packing inside. But with a novel technology, you can have a tubular reactor that has baffles. You can combine all sorts of things, and that's the innovation. And how is your project reliable to other countries like Norway, whose energy is 99% hydroelectricity? How will you justify your project? Well, it's not necessarily my project, but let's just say a project. How would you justify doing bioeconomy in Norway? I think every country in the world needs bioeconomy, because if you look at chemicals, they're in the products that we make today. They're in the chairs that we sit on. They're in the tables. They're in the tablecloths. They're in the computers. They're in our mobile phones. They're in the ladder. Every single thing that you can name in your room, the paints on the walls, that's from chemicals. So it doesn't matter if your energy is from 99% hydroelectricity. All the products that are in your house are from fossil fuels. So if you want to change as a global world, you need to change what you're making your products out of, because you're still digging the oil out of the ground or pumping it out of the ground to make those products. So yeah, that's why you need to, you can use raw materials like, vegetable oils, animal fats, and other natural ingredients to make those chemical products. And then you have, a t-shirt, which is, or a coffee cup, which is completely from natural ingredients and not one which is from fossil fuels.
Hi there, Thad. It's Adil.
Yeah.
Can you hear me?
Yeah, I can hear you.
I just wanted to thank you for today's presentation. And I just wanted to highlight two things and conversations that we've had recently. So basically, I came across PCMA a couple of months ago and just been working with them. And one conclusion that the industry leaders came up with was to install oil-based refineries, so steam crackers, etc., in Pakistan. And I remember my conversation that I had with you, and you mentioned maybe we should have done that 40 years ago. So what would you suggest, if we were going to go down the bio route and install biorefineries, what would you suggest? Where should we begin? What markets should we target? What products should we focus on? What feedstocks would you suggest?
I think in terms of feedstocks, if you're looking for the feedstocks, you really have to look at what is, available in Pakistan. A lot of, the vegetable oils that you have, they have actually very similar products within them. They just have different percentages of those, but you can, via different methods, you can extract those. So whether you're going to be using rapeseed, palm, coconut, that, you look at what's around you, what's available, and how much it costs as well. And then you also look at the cost of the process. So I would say what's best readily available in Pakistan is what you should really be tapping into as the ingredients and as the main ingredients. Of course, like Croda, there's always going to be potential some part of the ingredients that you're still going to need from fossil fuels to make the very specialty ingredients, but you're going to have the good, the large portion of your ingredients coming from, the stuff that you have available in your country and in your neighbors' countries, and that you can get readily available. And in terms of what markets that you should target, I'm going to say pretty much the same as what Croda's doing in terms of the biggest markets in the world right now are food and healthcare, because at the end of the day, population is growing all around the world. People need to eat, and farming is not a job with a lot of profits. The farmers all around the world, they're struggling to meet their yields. They're struggling to break even. So if you can make crop technologies that help farmers, that help agricultural companies to do better, you feed your country, you help the agricultural industry, and agriculture is a big part of Pakistan. That is something all around the world. There's no country where it's not important. Number one, feed the world, and number two, I think more in the Western world, you're seeing healthcare is becoming a big thing. Everybody wants to be healthy. That's it, and you've seen how much has gone into this COVID vaccine and the attention that's being given to COVID. But, equally, there's continuously, pharmaceutical companies are continuously innovating. So if you can become part of that pipeline, you can grow for sure. What I probably wouldn't go into, or I would less go into, is starting to go into automotives market, for instance, because if you're going to go into the automotives market, which one are you going to go into? Are you going to go into right now into the electrical one? Or are you going to go into the traditional gas, petrol, diesel market, and nobody knows which one's going to win yet? You can take a wager, but maybe people just won't drive at all, and they'll all take the bus or something, with hydrogen, and the hydrogen engine looks completely different from electrical engine or petrol engine. So that's probably not where I would go, but there's going to be definitely a lot in electronics. Electronics is a huge industry, and Croda, we're in the electronics industry as well. We're, like I said, water repellents on the coverings, glues going into the components, some of the plastics that are going into it, as well. So those are the big ones that I would say that you need to focus on if you want to look for the most promising future. The other markets are going to, be there as well, but those are the big ones.
Thank you, Torres. We have one more question from Dr. Aisha. What materials you prefer to build the baffles in reactors?
Those are metal. Those are just, stainless steel in general. And the whole reactors are just stainless steel that we're using in general. And that's, basically just because of, how stainless steel is able to go against corrosivity and temperatures and erosion as well, corrosion. So that's why we're choosing those kind of materials. Is it economical? Well, that's one of the things I was challenging in the beginning. Is it economical? And if you look at the beginning, the Croda share prices, Croda, we always been in the bioeconomy. We always been doing bio. They started off, doing lanolin from sheep's wool grease, you know. So that's how it all started, from the grease of sheep, and yeah, you know, and we have seen incredible growth in the bioeconomy. The bioeconomy is growing, so it can definitely be economical if you position yourself right. But like with every business, you know, most startups fail. Let's be honest about it, and that's not because the idea wasn't good. It's more because of the business plan. So I'm not saying that you do this and you're definitely going to make money. And I'm also not saying that, you know, if you right now have a chemical plant and it's based only on fossil fuels, you need to knock it down. No, because those guys, they have a different thing. Retrofitting is completely different from designing new. So if you're designing new, you've got to think about the future right now. You've got to think about where you want to be in 20 years. And this is, you've got to think about the bioeconomy. When you're thinking about what you have right now and you want to change that, then you've got to think about what's the best you can do with what you've got right now. And that is, and some things won't be possible. You know, maybe you won't be able to make some of the products. Some things will be. Some, you know, like I said, when you replace a fossil fuel material to a organic material, you know, it's just traditional chemistry going on there. So you can make that in the same CSTR potentially. So it's not such a big deal in that way. You know, you're going to have to, you know, talk to your clients and get new suppliers and all that kind of stuff. But you can do it.
So with that, something else just occurred in my mind. Yeah, it's the deal again. You mentioned how the growth of Croda was, in comparison to oil and gas industry, you experienced better performance. Could you elaborate on that?
Yeah, well, you can look at the stock prices of all the big oil and gas players, Bayer, BASF. You can look at all them. Some of them have been stable. Most of them have gone down. If you look at it, if you look at even, you know, and if you look at companies like Croda in the same time, they've been growing. Why is everybody talking about bioeconomy now? Because, you know, bioeconomy is making the money. That's the reason that they're talking about it now. So the biggest winners are the people like Croda who started doing it before, because they had, you know, a head start. They weren't winning for a long time, but now they're winning. So the next, but you know, just because you started first doesn't, it's the long road, right? Nokia also wants the winners in the mobile phone market, and then Apple came along, you know, and so just because you started first doesn't mean that you're going to win forever, you know. So actually, sometimes the people who come in later, they have a bigger advantage because they can see all the stuff that companies like Croda have done, what worked, what didn't work, and they can, you know, take that for themselves, and then they can put on their own strategies. And like I said, they might not have the legacy because, you know, with Croda, they also already have plants, you know, they can't do everything, you know, but when you're starting afresh, when you're going to build a new chemical factory, you can do anything you want. You can put in the latest technology. You can and you can make any product that you want because that you're starting afresh. So you can have actually the advantage of being the, you know, the second player and not the first.
Thanks for that. Thanks.
Are there any more questions from the members or participants?
So I think we have no more question. Thank you, Mr. Furness. Jason Furness. We have one more question in our chat.
It's like solar power.
Yeah. Solar powered food production might be a good option. Yeah, well, in terms of, I think you've got to split up two things, right? And you've got to think about the product that you want to make. I think anything in the food industry, fantastic. Second, the energy that you're going to do with it. You couldn't actually design them separately. You know, the energy, like I said, you can change later. And solar power, in terms of the sun, is readily available in Pakistan. Solar power might be the way to go. On several of our chemical sites, we have solar panels, and in the UK, we have some sites also with we have a wind turbine on one of the sites. So yes. And smart farming also helps with automation. Yes, smart farming helps, but it does. Does it help enough? So they still need the fertilizers and so forth, and the seeds and so forth to make it better. So some of the products we have is seed enhancement. It's not designing. It's not GMO. But sometimes with the seed, we can put a coating on the seed that will make the seed grow better. And, farmers around the world are buying these seeds that will just outgrow. And so they still need that. And in terms of books or literature to develop knowledge on the bio-based industry, I would say right now, even if you look at even if you look at the old school, there's a chemical engineering magazine called Chemistry and Engineering, CNN. That's old school. If you look at the articles now there, it's half of it is already about the bioeconomy. So actually, in terms of having to look specifically for bioeconomy, you don't really need to look specifically for bioeconomy in literature now to hear about the bioeconomy. It's in the mainstream literature of most of the chemical engineering magazines, even something like Hydrocarbon Processing, which was all about fossil fuels and petrochemicals, still talks about bioeconomy now, because a lot of the petrochemical companies are also starting to think, hang on a sec, how can we switch? So yeah. And our last one, biofuels made from processing are made from processing some raw materials, and these processes are carried by using equipment and machinery, and these machines run through electricity, which is made from hazardous fuels for now. So in the end, the matter again stuck on the electricity. What is the alternative for this problem? So I think people have the idea that all sites and electricity is generated from the grid. Now, that's not quite the case. In the current chemical industry, most chemical sites generate their own energy. They have coal-fired burners, or they have, natural gas-fired burners. They create their own steam they're using. Yes, by the even if when they switch to electricity, they already have a benefit because it's better than the coal that they were using themselves, and because the national grid is way better than what the chemicals company is using. They're just using the cheapest option. But the government eventually, I would say everybody here, go out and vote in the Pakistani elections and vote for your government and ask your government to move towards sustainable electricity. But they will move. But in terms of you can do a bit as a company yourself. You can put down your own solar panels. You know, like I said at Croda, we've done that, and some of our sites we have our own solar panels. Some of our sites we have our own biogas or own wind turbine. And you know, in some places we're looking right now at geothermal energy. So the company, they have money, you know, they can also make their own energy just the same way that they're making their own energy right now with using the coal fired burners. So it's, you know, ask as an individual, ask your government to move. As a person in a company, just do it yourself, you know.
यार कहाँ चले गए दोनों चले गए अब इधर आओ ना म्यूट अनम्यूट करो जल्दी से कहाँ चले गए यार छोड़ के अनम्यूट करो तो मैं बात करूँ thank you very much Mr. Tarius. I think this was very enlightening talk and that mobilized so many questions and queries. I think being first ever lecture or session on bioeconomy, I think this is very, very successful webinar by all standards. And we would encourage other speakers or thinkers who even participated or did not participate today's webinar to contact us, and we can discuss and plan their talk in future sessions. So let me thank once again Mr. Thaddeus for sparing time and giving this very enlightening lecture and talk. It has definitely mobilized the thinking and brainstormed the ideas which will go a long way in working together for the biochemistry and bioeconomy. And thank you very much. Thanks everyone who is.
Thank you.
Yeah, thank you.
Thank you. Thanks.
Thank you.